Hey everybody, this is Larry. This is day 10 of the Leetcode Day Challenge. Hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about today's problem. Yeah, hope I'm having a good day. I just kind of slept in all day and, uh, ooh, yeah, didn't do much. Just, just read up on the news and all these things. Yeah, let's. But tomorrow I am seeing the podiatrist for my foot again, so the doctor for the foot, the doctor. So we'll see how that goes. Today we have a easy problem, so let's just get through it, and then I could go back to bed. I'm not that tired, or I shouldn't be that tired. Honestly, I haven't done anything, but I just had a huge meal, and I think I'm just a little bit of food coma. So anyway, so let's take a look. It's an easy problem after all. So let's take a look. We have 3174, clear digit. You're given a string S, your task is to remove all digits by doing this operation repeatedly. Delete the first digit and the closest non-digit character to its left. Okay. Delete the first digit and the non-closest. Okay, I mean that... I feel like, it seems pretty straightforward, but it's a little bit awkward. So I think can you always do that? I think that's the question, right? Non-digit character to its left. Like, what if there's no what if there's no digits to its, or not? What if there are no characters to its left? Not that there are no digits. How do I click on this? I hate this new UI. Like, if we just have 5. Oh, okay. So, okay, never mind. The constraint. Oops. I locked my computer up. Okay. Yeah, the constraint said that there isn't. So okay. So again, ignore that. I think the key thing to note is that you can just go from left to right, right? And the thing is that every digit just matches a character to the left is a very stack thing to do. I almost honestly don't even know how to explain it really. I'm trying. I mean, but the thing is that there's no decision, right? So you can do it however you like. And also, honestly, as long as you, because the query that you're trying to, I think, okay, let me try a little bit, right? Because I think having a good grasp of this idea helps you with harder problems, right? Like, this is an easy problem, it should be okay. The idea behind this, let's try to think about it without, because I think I talk about this with respect to mono stacks and stuff like this, and I think it's, I get it that sometimes I don't think I could explain it that well, or it's a little bit foreign of a concept. But this one, it's a little bit easier, right? So first of all, what would we try to do, or how would we do this if we're not able to use a stack, right? Or not even have to, just like, if we want to be as naive as possible in this problem, n is equal to 100, so you actually can do that, right? Then what would you do? Well, you would have write something like this. I don't know why I would say a little bit. For I in range of n, and then if s of I is equal to or is digit, then now we want to go to the first first character on the left, right? But we also want to make sure that it's not used, right? So we want to have like maybe some sort of like used is equal to 4 times n, right? So then now we go for j in range from I minus 1. And then just go all the way to the left, right? So if s of j is character, is it is character? I forget what it's called. It's alpha, I think, actually. Alpha and not used sub j, then u sub j is equal to true, then we can break, right? And then at the end, we just remove all the digits and all the used, and we should be good, right? So here, maybe we go answer for I in range of n. If s of I is alpha and used or is not used, then answer that append s of I, and we are good, right? I forgot to convert it to a string. Okay. I was like, how can I mess this up? I mean, I can mess this up. I feel like I've made a lot of things up, right? So this is probably mostly good. I'm not gonna submit it just because, whatever, right? And then the idea here is the same idea. If you want to really get a deep understanding of implementing this using a stack, it's about thinking, okay, well, with the same idea with monostack is that So if you take a look at the used array, and we could trace for an example, right? And I'll do it for ASCII art. I don't need to draw it, right? Hopefully, we can just do like I'm banging on the keyboard, a couple of numbers, whatever, right? And then the idea here is that as you go from left to right, you have a used array, but here you go 1, right? What does this 1 do? Well, this 1 will match up with this y and then mark it as used, right? Straightforward. And then now we have a 5, oh no, sorry, a 2, and then that matches with the j, right? And it matches the j with the j by going one step at a time, from 5 to 2 to 1 to y, oh sorry, from 2 to 1 to y to j, right? And so forth, right? And okay, so then now, why do we want to use a stack in this case, right? 5 matches to k. So the reason why we want to use a stack is because how I would think about it, this one, and honestly for this one, it just kind of seems so innate to me because I've just done years and years of practice that I don't even know how to get to it. So this is kind of my exploration of explaining it to y'all, right? The idea here is that, okay, well, if we kind of keep on going back and forth, it's going to be n squared, very clearly, right? And what I mean by that is that we have like, we don't even, it doesn't even matter what the character is, right? It's just, let's say you have half alphabet and half digits, right? Then now this will move 1 to the left, this will move 3 to the left, 5, 7, 9, dot dot dot, and that of course is going to be n squared. And you could even, and in fact it's exactly, well it's not, it depends on what n, but exactly square, right? Because 1 plus 3 is equal to 4, plus 5 is equal to 9, plus 7 is equal to 16. And the reason why I knew this is just some of his practice, but you can actually add it with visualization. This is a little bit of a sidetrack, my fault. But yeah, because then now you could draw 1, and then 3 is going to be just 1, 2, 3, and then 5 is going to be 1, 2, 3, 4, 5, and then so forth. And you kind of figure out, and that's why it's n squared. Comes in handy in other problems. This is already too much of a sidetrack. But my point is that this is an n squared kind of thing, and for this problem, obviously it doesn't matter, but for a bigger n problem, then it's gonna, you know, you're gonna run out, right? Or you're gonna time out, right? It's gonna be too slow. Anyway, so then the idea here with the stack is going, okay, well, how can we eliminate things in such a way so that we don't look at it again, right? So maybe you could think about it even like in a weird way, almost like a linked list, right? Of like, okay, there's an A connected J, K, and then J, and then when you say have 2, well, we remove the linked list item. Or okay, let's start with E and 1. We remove the linked list item so that we can skip. Then 2, the first thing we look at is J. So that's really the entire idea by the stack, is that if you can't think of the stack as a linked list first, then now you're just skipping things to remove, right? And the reason why you can use a stack is that, and then now the next point is that, oh, we don't need the first linked list, right? We only need the end of the linked list. And that actually matches the characteristic of a stack. And of course, just to be clear, a stack can be implemented with an array or a linked list, right? There's nothing to say that, you know, a stack by itself, technically speaking, is an abstract data type and can have many implementations. Of course, an array or something similar, or a list, is going to be more efficient for reasons that I'm not going to go into right now. In general, with respect to like memory access things, but so there are a lot of things we can go into with that. But the idea is still that, okay, well, you're only popping off literally from the back, so we have a data structure that we can think about, and then that's where stack comes in, and that's where you can think about all these things, right? Yeah, that's basically the core idea about this. I know that this problem is very basic and it's very easy to kind of feel intuitive and just be like, oh, it's a stack because I recognize it's a stack problem, which is maybe true, but there are a lot of other harder stack problems that are just harder, right? And as a result, then you might not be able to kind of, you know, pick them up because you did not build up those little nuggets of knowledge and practice on the easier ones. Anyway, let's actually solve this one real quick because I want to get credit or whatever. So yeah, so for x in S, if x is digit, then stack.pop. What? Why would it add an extra one? Oh, sorry, I misspelled digit, didn't I? How did that I move like 4 spaces away? It's crazy. It'd be great. And then that's it, right? Pretty straightforward stuff, in theory. Not, you know, but I think sometimes it's easy to kind of not think about these things in general. And I made a 10-minute video on a very easy problem, so I don't know. Anyway, that's all I have for today. If you're here for whatever reason, hope you kind of enjoyed that breakdown of a relatively simple problem. But I suspect, and I'm not gonna lie, the reason why I say that is because until doing it today, I didn't really think about it. I would just be like, oh yeah, it's a stack problem, and that's it. And I don't know how much of it is memorization, muscle memory. There's a lot of things, but you know, you want to get better, you want progress, you have to kind of slowly build out the why, so that when you run into stuff like a monostack, for example, right? If you're struggling with monostack, it may be honestly that, you know, you did not necessarily build all the things of a stack, and some of it is just tough, right? Because people tell you what a stack is, but they don't. But you have to kind of learn how to use it, right? So it's not just about you know, knowing what things are, right? Everyone knows names of things. It's fine. You can look that up. And now, especially with ChatGPT, you can know the name of things. Name of things does not equal to knowledge. But anyway, that is all I have for today. Let me know what you think. Thanks for watching. Have a great week, everybody. Stay good. Stay healthy to your mental health. I'll see y'all later and take care. Bye-bye.